Hi, welcome to Mr. Crow's Classroom. Today I'm going to introduce logarithms, and logarithms have a reputation for being somewhat complicated. However, they really don't have to be. In fact, they are actually pretty simple by nature. So hopefully I can explain why that is. So let's go ahead and check them out. Okay, so we're going to start with just talking very quickly about a few different operations and their inverses. If you want a detailed explanation of this table here, where I go into great depth just talking about how I created it, then go ahead and see our exponential functions introduction video, and that will be there. Okay, so but I'll just brush over this here. So first of all, on the left-hand side of this table, we have all of our basic operations, and we really just start with addition, and just showing here that we have this plus operator, and we're just adding 1 plus 1 plus 1 to get some kind of value here. Now the inverse operation, or how you undo the addition, is going to be subtraction. And down here to the left, we have middle left here, we have multiplication. Now, why did we create multiplication? Well, if you look up at this example above, I have 1 plus 1 plus 1 plus 1, and after a while doing mathematics like that can get pretty tedious. So we created an operation to fit this pattern called multiplication. Here I'm adding 5 ones, but I can shorten that by just saying 1 times 5, right? And that gives us our multiplication operation. Now, in order to undo multiplication, we have to have some kind of inverse if we want to solve algebraic equations. Or solve equations algebraically. And of course, we have division. So, and division really is if multiplication is just repeatedly adding the same number, division is repeatedly subtracting that number. Okay, that's really all it is. All right, and then of course we're gonna move on down to the lower left where we have exponentiation or exponentials. And again, this just was created because we got tired of writing the same thing over and over again. If you look up here, we have 1 times 5 times 5 times 5 times 5 over and over and over again, 5 times. And so instead of writing all of that out, we can shorten that by saying 5 to the 5th power. Okay, and that just means that we're going to multiply by that, we call this a base, 5 times. Now, of course, if we have an exponential, that's the operation here, then we have to have some way to undo that, and that's really what today's lesson is about, and that's called a logarithm. And so how is this the opposite? Well, with exponentials, you're simply repeatedly multiplying by a common number, a base, the same number, and a logarithm is simply repeatedly dividing by a base. That's it. That's all a logarithm is, okay? In this particular case, if we took log base 5 of 3,125, really the actual question that is asking is how many times would I divide 3,125 by 5 in order to get back to 1? And actually, you can see over here, that's why I put 1 times 5 to the 5th power. You might be wondering why that was out there. Well, we're actually starting with 1. That's the multiplicative identity, and so we start with 1. But anyway, if we're going the opposite way, we're going to go back to 1, okay? It's kind of like with addition. 0 is the additive identity, so we start with 0, add a bunch of 1s. When I subtract 5 minus 1s, we want to get back to 0, essentially, okay? All right, so let's go ahead and take a look at some of these in action here, right? Because you've definitely seen this before, 5 plus x and 5 times x, and we know to undo this 5 plus x, we're going to, if I want to isolate x, that is, for all of these, I'm going to subtract 5, right? If I subtract 5, that's the opposite of adding 5, and so I'm going to isolate my x there, okay? Or just get x back. All right, if I want to do the opposite of multiplying 5 times x, then I'm going to divide by 5, right? Opposite of multiplying by 5, or the inverse, is dividing by 5, and then 5x divided by 5 is going to leave my x all alone. So the real question here now is, if I have an exponential, meaning the variable is in the exponent, 5 to the power of x, how in the world do I get that x out of there? Well, what is the inverse of an exponential? Well, it's a logarithm, and specifically, this has a base. This exponential has a base of 5. I'm multiplying by 5 over and over again, so I have to take a logarithm with a base of 5. So what is that going to look like? Well, on this side, I'm going to take the log base 5 of this exponential, and since these have the same bases, this exponential is base 5 to the x, and we have a log base 5, then these are going to cancel out, leaving us just with our x. And actually, tomorrow or in the next lesson, we're going to talk about all of the properties of logarithms as well as exponentials, and you'll actually see that this creates one of our rules. Okay? But anyway, so if I want to undo an exponential, I'm going to take the logarithm, and they just have to be the same base. Okay, and by the way, the opposite is true as well. If I have log base 5 of x, then and I want to get this x out of here, well, what's the opposite of a logarithm? Well, the opposite of or the inverse of a logarithm is an exponential. So I would actually take this as an exponential. What does that look like? Well, I would take this whole thing, and I would take the base of 5 to the log base 5 of x, and that is totally legal. We can do that. And so just like up here, if I had log base 5 of 5 to the x, well, here I have 5 to the log base 5 of x, and again, these are going to cancel each other out here and leave you simply with x. Okay? And again, if that's confusing to you, it's okay. In the next lesson, we will go over these properties and show how these work. All right, now again, I just want to repeat, why does this work? Well, you have to be very careful. You have to make sure that you are taking the same base, okay? The only way that you're going to get these things to cancel out is if you have the same base, okay? All right, let's go to the next little section here. Okay, so I'm going to talk about, just simplify what I just talked about, and we're going to talk about the basic form, right? So if I have some b to the x, some kind of base, any generic base, could be 5, could be 10, could be e, right? It could be pi, could be anything, really, any number. But anyway, if I take log of that same base, right, then those are going to cancel each other out, just like addition and subtraction cancel each other out, and multiplication and division cancel each other out. These are going to cancel each other out, leaving you with that exponent. So that is going to equal x. And then the opposite, like I just showed you, is true as well. If I have an exponent, b to the power of something. Now this power, looks crazy. It looks a lot crazier than anything you've probably seen before, but it is totally legal to have a logarithm up there. But anyway, if I have an exponential, the base is this number down below, right? And then if I have a logarithm, I have the base here as well. And as long as these bases are the same, okay, then these are going to cancel each other out and again leave you with x. Okay, so I want to talk about, this right here. So this right here is a common way that we change exponentials to logarithms and logarithms to exponentials, going back and forth. So if I have an equation like this, y is equal to b to the power of x, which is basically like a parent function there. That is actually equivalent, 100% equivalent to log base b of y is equal to x. And I'm going to go ahead and show you how this relationship works, because it's actually pretty easy to shift back and forth from an exponential equation to a logarithmic equation and back. So let's go ahead and take a look. Okay, so in this one, you're seeing that we have an exponential, right? This is 2 to the power of 3. The base is 2. That's important. The base, right? We really need to know what our bases are here when we're talking about exponentials and logarithms. But anyway, we have the base of 2 to the third power is equal to 8. Well, why is that? Well, 2 times 2 times 2, 3 times here, is equal to 8. So how would I actually shift this back and forth to a logarithm? What is the equivalent statement? Well, this has a nice little animation. Let's go ahead and do it. And so you can see the exponential base of 2 up here, the exponential base, it actually just gets moved to the logarithmic base. So it's this equivalent statement is saying log base 2 of 8 is equal to 3. These are equivalent, and you can move back and forth at will as much as you want. So for example, if you don't like logarithms, right? If I don't like if I saw this log base 2 of 8 and I didn't really know what to do, well, if you know how to transform it into an exponential, where we just move that base into the base of the exponential and the number that it was equaling gets moved up to the exponent, then you can transform it, and vice versa. Now I'm going to highly discourage that because again, logarithms are not some mystical thing. It is they're very simple. What is this problem actually asking me? The base is 2, and remember, logarithms are opposite of exponentials. Exponentials were continuously multiplying by the base. A logarithm, we're dividing by the base. So what is this asking? This is asking, hey, if I'm starting with 8, how many times do I have to divide by 2 to get back to 1? In this case, the answer is 3 times. 8 divided by 2 is 4, and then 4 divided by 2 is 2, and then 2 divided by 2 is 1. And we did it. We divided by 2 3 times to get back to 1. Okay, that's what this is actually asking us. Okay, let's go ahead and get back to the notes. Okay, so now that you can actually see here that these are equivalent, y is equal to b to the power of x is the same thing as log base b of y to the x. Let me go ahead and show you a proof based on these two properties over here. Again, just properties of inverses, I guess, showing that these are equivalent. So if I start on the left-hand side, my goal is going to be to get this to end up being log base b of y is equal to x. Okay, so let's go ahead and do it. So what am I going to do? Well, I need to get this x out of here, right? I need to get the x out of this power. So what is the opposite of b to the x? Well, or the inverse of b to the x, the exponential b to the x? Well, log base b. Log base b is the opposite. So I'm going to take log base b of both sides. And on the left-hand side, I can't really do anything. This is just log base b of y. Can't go anywhere from there. But over here, I have log base b of b to the x. And you're actually seeing it over here, right? This says if I have log base b of the same base to the power of something, then I just get that power back, right? And so this over here on the right-hand side is actually equal to x. And now, what have we done? Well, we actually came up with these equivalent statements. Log base b of y to the x is equivalent to y is equal to b to the x to the power of x. And again, we're just applying our inverse. That's all we're doing there, okay? It might seem a little weird, but that's just because you haven't really done it too much. All right, whoops. And again, taking like these equivalent statements, this is exactly the same thing. Like when I say that, you know, this exponential is the same thing as this logarithm, that's the same thing as saying, well, if I have you know, x is equal to y, then I could just have 0 on the other side. I could subtract. This is addition and subtraction, right? I'm just applying the inverse property, and these are equivalent, right? Or this one right here, this multiplication, x times y is equal to 1. Well, I could divide, use that inverse property, and I could say y is equal to 1 divided by x, right? All I'm doing here is applying algebra, right? And I'm just applying the inverses for each operation. That's all we're doing, okay? All right, now to help you think about solving these, because now we're going to get into actual problems, right? We're going to talk about the scale, all right? And first, let's talk about the linear scale, because that's what you're used to. You guys have been using this linear scale for ages, it seems, right? And what I want to do is show how that's built, and then we're going to go ahead and build what we call the logarithmic scale, okay? So let's go ahead and start. So how is the linear scale built? And this one is just going by tens. Well, how would we build that, right? Well, we just simply start at 0, right, in the middle, and then we're gonna keep adding 10 to go to the right, and we're gonna subtract 10 to go to the left to get our positives and our negatives. That's pretty much it, right? It's pretty easy. Okay, so let's go ahead and use an example here. Like, how would we actually use this scale? Well, if I had 30 minus 40, well, what could I do? Well, if you go all the way back to like 3rd and 4th grade, well, we'll start at 30 here, and we're gonna go to the left 40, and we end up at negative 10, so the answer is negative 10. In other words, I'm subtracting 10, subtracting 10, subtracting 10, subtracting 10, 4 times, and I get negative 10. Okay, so now let's go ahead and build on this, and we're going to build the logarithmic scale. Now, just like we had the 0 in the middle because for the linear scale, and that has to do, by the way, with 0 being the additive identity. Well, the multiplicative identity is 1. So 1 is going to be in the middle here. In fact, we won't have any negatives. Okay, those don't exist on the logarithmic scale. All right, and so let's go ahead and build this. So remember, with linear, we're just adding and subtracting, and with logarithms, and actually you could also call this the exponential scale if you wanted to. I really don't know why they call it the logarithmic scale, not the exponential scale, but that's what we typically call it. But anyways, if you want to go to the right, then you're simply going to multiply by 10. In this case, I'm going to use base 10, but remember, you can use any base you want. It could be any number, base 2, base 3, base 4. I'm just happen to be using base 10 because it kind of matches up. But anyway, to go to the right, what did we do? Well, we simply multiplied by 10, right? Because that's what we do. Instead, with linear, we add and subtract, and logarithms and exponentials, we're going to multiply and divide. So I'm going to multiply by 10. So every time I move over 1, I'm going to say 1 times 10. Well, that's 10. My next little tick over is 10. And then times 10 is going to be 100. And then the distance of 3 over is going to be 1,000. All right, and let's go ahead and move to the left. Right, and you got it. We're just going to simply divide by 10 to move to the left. So 1 divided by 10 is 1/10. And then divided by another 10 is 1/100th. And then 1/1000th, and so on and so forth. So this gives us our logarithmic scale. And so how do we answer questions based on this scale? And I kind of already alluded to it in this last example here, but let's go ahead and do some of these, okay? And let me remove this example. Okay, so here we go. So here's a problem for us, right? We have 10 to the power of 3. This is an exponential, right? And so what is 10 to the third power, and how would we use this logarithmic scale to do it? Well, we simply start at 1, and then we're going to multiply by the base 3 times. So times 10, times 10, times 10, and that gets us all the way over to 1,000. And so 10 to the third power is 1,000, right? We're going 3 spots over, okay? Let's do another one now. And let's do a logarithm. So now, remember, with exponentials, we're multiplying by the base. And with logarithms, we're simply dividing by the base. And remember, with exponentials, we start at 1 and move away. But with logarithms, we return back to 1. We're going to continuously divide till we get back to 1. Okay? So what is this question asking us? Log base 10 of 100. Well, that's asking us, and remember, the base is 10, but that's asking us, hey, if I start at 100, how many times do I have to divide by 10 to get back to 1? Well, in this case, go ahead and bring this up. In this case, I'm going to start at 100, and I'm going to divide by 10 once, and then divide by 10 again, and I'm back to 1, right? And so the answer of log base 10 of 100 is 2. I got to divide 100 by 10 twice to get back to 1, right? Pretty easy, right? They're really not that hard. All right, let's continue on. Let's do another one. So this one is a little bit harder. All right, and so in this one we have, whoops, hang on one second. All right, so in this one we have log base 10 of 1/1000th. Okay, so that's a little freaky looking, right? But it's not that hard, right? Let's start at 1/1000. So we're going to start over here. And what do we need to do to get back to 1? In other words, how many times do I have to divide by 10 in order to get back to 1? Well, this one's a little bit tricky because we don't divide by 10. In order to get back to 1 from this side, we have to do the opposite. We have to multiply by 10. So we're going to multiply by 10 once, twice, 3 times. So if we're doing the opposite of dividing by 10, we're multiplying by 10 3 times. We could say we're dividing by 10 negative 3 times, right? That's what this is asking, right? How many times do I divide by 10 to get back to 1? Well, I'm not. I have to do the opposite. I have to multiply by 10 to get back. So that's why it is negative. We have a negative 3 times. Okay? All right, I got one more example for you. So in this example, I have log base 10 of 500. Now, you might naturally say, well, 500 is divisible by 10. But actually, remember, we can only divide by 10. All right, so what does that actually mean? Let's take a look at that, okay? When we're talking about logarithms, we cannot change about how much we're actually dividing by. It has to be by 10. So if I put 500 on this scale, where is it? Well, it's actually not right between here. It's like it's a lot closer to this 1000, but it's between 100 and 1000. And by the way, if I took the log base 10 of 100, that would be 2. I would divide 2 over. If I took log base 10 of 1000, that would be 3. So actually, what we know for the log base 10 of 500 is that it must be somewhere between 2 and 3 times. And actually, we don't really know. And we wouldn't really be able to do this by hand. We would use our calculators to do this. Okay, so if you did plug this into your calculator, is it actually between 2 and 3? Well, let's go ahead and look at the solution. Yeah, the solution is actually 2.69897 ... It keeps going on. I don't know if there's if it repeats or anything like that, but it looked like it went on forever, at least in my calculation. Okay, but anyways, so really by hand we could just say, well, if we drew the scale out, like we kind of know what it's between, but it's going to be some kind of decimal. Okay, all right, let's continue on. Now I want to talk about just a couple of conventions very quickly. And because these are going to be very common. So the first convention is log base 10 is what we call our common base. Base 10 is the common base, right? Because it's the most common that you see. So because it's the common base, many times you actually won't see them write the base down in the problem. So if you see a log without a base, then that means it is base 10. It's inferred that it is base 10, okay? Also, if you ever have log base e, right? E is Euler's number, and this is called the natural base. E is the natural base. So if you ever see log base e of x, well, you actually probably won't see it that often. You'll actually see ln of x. So if you ever see ln of x, it is the same thing, and it actually can be very helpful to rewrite it as log base e to the x, right? ln is actually, I think it was originally Latin for, it just stands for natural log, but in Latin, essentially. So it's like logarithm natural or something like that, okay? But really it just stands for natural log. So both of these, I would highly recommend, if you see log of x, I would rewrite it in my problem as log base 10 of x. I would put that 10 in there. And if you saw ln of x, until you get really good at natural logs, I would probably rewrite that as well as just log base e of x, right? It's just base e. And remember, e is a constant, just like pi, right? It's an actual number, it just happens to be irrational. It goes on forever, okay? So we don't want to write that thing out forever, so we just use a letter to substitute, right? And we use e for the natural, this natural base, okay? All right, so those are some of the conventions. And now, finally, let's go ahead and do a few examples without the number line. So how would I actually solve these without the number line? So let's go ahead and do this. All right, so for example 1, I have here log base 2 of 64. And so let's go ahead and do this together. So how would I do this? Well, I would, if I didn't use a number line, I would literally start with 64 and I'd just start dividing by 2 until I got back to 1, and then I'd count how many times did I divide by that base, okay? 64 divided by 2 is equal to 32. And then I'm going to divide by another 2, and that's equal to 16. Divide by 2 again, and that's equal to 8. Divide by 2 again, 4. Divided by 2 is 2. Divided by 2, and finally I get 1. All right, now the question is, what is this actually asking? Remember, it's how many times do I divide 64 by the base 2 to get back to 1? Well, how many times was that? Well, that was 1, 2, 3, 4, 5, 6. So this answer is 6. There you go. So log base 2 of 64 is 6. All right, let's go to another example here. So here I have log of 1/100th. So remember here that if you don't have a base, then that is the common logarithm. So the base is 10. And so again, we need to say, or what is the question here? It's saying, hey, how many times would I divide by 10, the base, in order to get back to 1? Well, whenever you start with a fraction, you already actually know that it's like you're going to have to do the opposite, okay? So I'm not going to be divided by 10. I'm actually going to have to multiply by 10 to get back to 1, which means I'm going to get a negative since I'm doing the opposite number of operations. So let's go ahead and do that. So I'm going to start with 1 over 100, and I'm going to multiply by 10. So that's once, and that is equal to 10 over 100, which is 1/10. Okay? And I'm not at 1 yet, so I have to multiply by 10 again. Keep multiplying by the base because we're going in the opposite direction here. So let's see here. 1/10 times 10 is equal to 1. And now I am back at 1. So the question is, how many times did I divide by 10? Well, I didn't. I multiplied by 10. And in this case, I had to multiply by 10 once, twice. So the opposite of division is multiplication. So this is equal to -2, right? I had to multiply by 10 twice. So it's -2. All right, let's see here. One more. And this one is actually, I'm giving you a kind of a double here. And so these are pretty common. You might see quite a few of these types of problems. And these are the easiest ones, actually. So in this case, I have log base 7 of 7. So the question is, how many times would I divide 7 by 7 to get to 1? Well, it's just one time, right? 7 divided by 7 once is equal to 1. So whenever you actually see the same base, and actually you can even think of this if you think of this as 7 to the first power before, when we had the same base and you got the power back, that is simply equal to 1. How many times do I divide 7 by 7 to get back to 1? Well, just one time. All right, so that's pretty common for you to see that. Also, this one right here is very common. Log base anything, I thought about putting some huge number in here just to throw you guys off, of 1. Well, how many times would I divide 1 by that base in order to get back to 1? Well, I'm already at 1, so no times, 0 times, right? So log base anything of 1 is always going to be 0 because I'm already at 1. I don't have to divide at all, okay? All right, so there we go. There was a basic introduction to logarithms. Hopefully it demystified them a little bit for you. Yes, it is a new notation, so you'll have to have practice, getting used to that. But really, it's a simple idea. Exponentiation is repeatedly multiplying by a common base, a common number, and logarithms are simply repeatedly dividing by a common base, and that is it. Okay? All right, so hopefully you found this lesson helpful, and I hope to see you in the next one. Bye now.